What up? We're back on to the second day for a similar triangle unit, and today you are going to learn why we had to review ratios and proportions. So before we talk about what a scale factor is, I want to go back and remind you on what similar means, because that's really what we're going to work on this whole unit. So similar means that they are the same shape, but they are different sizes. So I have a picture that can kind of explain what this means. So let's say that we had this picture right here. Okay, these little turtles. And I'll turn them into triangles so you can kind of see where I'm going here. But let's say we have congruent. Congruent, if you remember, meant exactly the same. So the same exact shape, everything's the same, all the sides are equal, all the angles equal, we're good to go. Alright, in similar though, see how it's a turtle, however, one turtle is smaller than the other turtle. These are considered similar, which means that they're the same shape, they're still a triangle. In fact, they're still maybe, equilateral. They're still 60, 60, 60, but clearly one of them, maybe the sides are 2 all the way around, and this one is 6 all the way around. So that's the difference between congruent and similar. So this whole unit is on what to do with similar shapes, specifically triangles. Alright, so let's go to scale factor, because that's going to be what we're going to work on today. Scale factor, the definition for scale factor, is how much bigger or smaller a shape is. So for example, if we go back to the turtles and you have this little guy here, you could say that this turtle is 2 times as big as the smaller turtle. This would be a scale factor, how much bigger the turtle actually is. Could be 2 times as big, 3 times as big, maybe half as big, 4.5 times as big, but a scale factor will tell you exactly how much bigger a shape is than the other one. And it's made by a ratio, so that's where our ratios come in. So we have to make ratios. It's the ratios of the sides. Okay, and I'll show you that example in a minute. And when you do this, you want to make it division and actually make it down to one number. And again, I'll show you all that right now. We're going to jump right into some examples. Here we go. Alright, first example. So here we have 2 triangles. Bear with me, they're supposed to look similar, same shape, different sizes. The one on the left is clearly bigger. So I'm going to go ahead and name this triangle ABC and name this one DEF. And when you talk about triangles, remember how in congruent triangles we used this symbol? In similar, you use just this guy here. You don't use the equal sign. So for example, you would say ABC, triangle ABC, is similar to triangle DEF, which means again that they're the same shape but they're different sizes. So we're going to find out what is the scale factor for this. So I'm going to throw some numbers on here and show you how it's done. So let's make this side 7, and we'll go 8, 5, 3.3, 4.6, and 5.3. Alright, so to find the scale factor, what you have to do is you have to match up the sides that are the same, side that matches up. So it's just like congruent triangles. So AB would match up with DE. So this one right here matches up with DE. So you're going to make that into a ratio or a fraction. So that will be 7 over 4.6. And then what I want you to do is actually divide that out. And when you do that, you would get 1.5. I'll go ahead and do that for you. Don't worry about it right now. Alright, let's get a different color going on here. Let's use black. So the next one would be BC goes with EF. So BC and EF will be together in a fraction. So that'll be 8 over 5.3. And again, if you divide this out, actually do 8 divided by 5.3, you will get 1.5. Alright, one more. Let's say that we are going to do AC and DF, because that's the last pair that match up. So 5 over 3.3. And again, that will give us 1.5. So what this means is that they are similar, and they're similar because ABC is 1.5 times bigger than DEF. Okay, you don't have to write that all like every time you do these problems, but I want you to understand what these numbers actually mean to your life. Okay, let's look at another one. Okay, this time, again, I'm going to name these. So we will name them ABC again and DEF. So this time, I'm not going to tell you if they're similar or not. What we're going to do is we're going to figure out if they are based on their scale factors. So hopefully you can tell which sides match up with which here. So let's start with, let's do the hypotenuse. So AC is going to match up with FD. So that'll be 15 over 11.5. If we divide this out, this is going to give us 1.30. I'm going to go two places just to be more accurate with this one. Alright, if I do, let's do the other leg that's going vertical here. So if I do AB and ED, that'll be 12 over 9, which will give me 1.33 repeating. Alright, so right away you're looking at these and you're seeing that these scale factors are different. So since they're different, right now, these are not similar shapes. So you can tell by the scale factors, all the scale factors have to be equal. Now just for the sake of it, I'm going to do the last one, BC and FE, which is 8 over 6. And 8 over 6, if you divide it out, is also 1.3 repeating. So these, again, are not similar because the scale factors do not all match. So that's how you can tell if they're similar or not. Alright, one more example just to show you now how proportions are related. So this is how we relate scale factors to ratios. Let's see how we do proportions to these scale factors. Alright, so I'm going to give you a second to copy this down. I'm going to keep rolling with the music, couple seconds. Alright, let's take a look here. Now, we're going to use scale factors to help us find x and y. So these are similar, which means that we can set up ratios which will lead to a proportion to find out what x and y are. So if we look at these triangles and we try to match the sides of them, I'm just going to color code to help you. So right here we know that AB matches up with YZ. So I'm just going to color code these in yellow so you know that those would match up to be a fraction, y over 4. Okay, let's do another one. So BC is going to go with YX. So BC goes with YX. So that ratio would be x plus 2 over 3. Then the last one would be AC matching up with ZX. 18 over 6. So this here is going to be the one that's helpful to us because 18 over 6 is the only ratio of sides that doesn't have a variable. So we need that because it'll be really helpful. So we're going to use this to help us. We'll do y first. So 18 over 6. This isn't a fraction again because they match up on the same side. So if I want to find y, I'm going to put y into its ratio, which remember was the yellow one here, so y over 4, and I'm going to set them equal. So 18 over 6 is going to be equal to y over 4. And again, that's because they're similar. Since they're similar, we can't set them equal, but we can set their ratios equal. So 18 over 6 equals y over 4 would be how we could solve for y. So then we would cross multiply like we've been practicing. So 6y equals 72. Divide by 6 and you'll get y equals 12. Okay, now to get x, you'll do the same thing. I personally would go ahead and choose the 18 over 6 again because that's the one that I know. Now you could plug the y in here and make 12 and do 12 over 4 and blah blah blah, but I'm going to stick with the 18 over 6. Then you could put the x plus 2 over 3, because again they're a ratio, and they match up, and then you make that proportion. Now you can solve for x. So do what we just practiced, cross multiply. Remember, you have to distribute here, so that'll be 6x plus 12 equals 54. Subtract the 12 on both sides, and we get 42. Divide by 6, and we get 7. Okay, so hopefully that helped make a connection between why we needed to learn ratios and proportions and how they're related to geometry.